Welcome to today's presentation, Delivering Reliable Apps at High Velocity with Continuous Automation. Let's go ahead and get started. Matt, why don't you kick us off by telling our audience what we'll be covering here today?
All right, thanks, Jamie, and hello, everybody. Today we're going to talk about Chef's perspective on, how are companies at a high velocity moving towards, a continuous automation future. We look at the pattern of detect and correct and automate. We really believe that we have a way for organizations to understand what's going on, automate all the things, and get to a place where you can really focus on delivering value rather than having to go through a lot of rote tasks and continue to do the same thing over and over again manually, and instead take advantage of the latest innovations of automation here. In today's webinar, we're going to talk about a little bit of an overview of Chef and what's going on in the industry broadly. And then what's really exciting is that Nick Rycar, who's a technical product manager on our team here, he's going to run through a real demonstration of the product in action and show what you can expect with the Chef platform as you're looking to automate your infrastructure and your applications and your compliance and move towards this continuous automation reality. First, I want to give a little bit of background about Chef for those of you who may be new to our company. We've always been a leader in automation, beginning with automation engines for infrastructure in Chef, compliance in our InSpec product, and then most recently with applications, we've been delivering automation through our Habitat project. All of our projects are developed with open source contributions and governance and have a wide range of contributors and committers from individuals to large organizations. What's great about this is it really allows us to tap into the promise and opportunity of open source projects because you need to get the combined knowledge, experience, and practices in making these projects the best in their class. Chef really made our name with being the first company to provide testable infrastructure and continuous compliance capabilities. And now with Habitat, we're delivering on automation that travels with the app, which is an alternate way to consider application packaging and delivery for a cloud-native world. We'll talk about our overall platform later, but right now I wanted to really reemphasize that we believe that automation is at the foundation of any successful digital transformation effort, and it's really the key to high speed, efficiency, and low risk in your application and infrastructure delivery. Other things about Chef is that we work with 70% of the Fortune 500. You can see the customers that are listed here really represent a wide range of industries from kind of born in the cloud companies like Facebook to manufacturing to transportation, financial services. So that breadth of customers really gives us a lot of great feedback in terms of what are customers looking for and help us to give that feedback to continually evolve and open up our platform. In addition, you'll see the partners that we work with are the ones that that are really the leaders in the space right now. That really are going to be making up, what does a hybrid infrastructure look like as you move forward. One of the other things that we think is kind of an exciting point here is that we're the only private company that's been appearing on a recent Goldman Sachs spending intention survey. So we, as we are, as much as we have the heart of a startup, we really operate at a level of enterprise enablement, which I think gives companies a great way to move forward while doing it with trust. Now what I want to do is really what's happening in the industry right now. I mean, we hear a lot of things, there's so much disruption going on, but as we think about all of the different evolution of cloud and containers and so on, one thing remains constant, and that's that getting automation right matters. Everybody's job is to take the great ideas you have and to ship them at velocity with great frequency and a high degree of reliability. The key here is that no high velocity company has been able to achieve that state without having automation as a foundation. If you're doing things manually, by definition, you're not going to have high velocity. And the reason why delivering at high velocity matters, it's really that when you deliver at velocity, you will outperform your peers. And when there's studies out there that show high performing IT drives 5 times revenue growth, and they're 2 times more likely to exceed goals. And why does this matter? When you grow faster, you can see the McKinsey report here. It shows the five-time improvement of being a top quartile digital company versus a laggard there. That as you deliver things quickly, your IT then drives outperformance. Pick your metric here. Is it on revenue, market share, productivity? Being able to automate and be able to deliver at high velocity gets your business to the place that you need to be to stay competitive in this environment. And then finally, you can just look across the board. the different success metrics that you can start impacting with automation. Everything from, and again, these numbers are kind of crazy. We think about delivering 46 times more frequently, 96-time improvement in recovering from failures, 5% lower change failure rate, and 440 times shorter lead times. Again, these are all almost hard to believe numbers, but what's amazing when I talk to customers here is that as they're becoming these high-performing organizations, these numbers really manifest themselves in satisfaction, just an enablement that you're getting your ideas in front of your customers faster than ever because you're worrying about delivering value, not about delivering automation, doing manual tasks to get your infrastructure up and running. As you're thinking about your own personal organizations, this is kind of a handy way to think about how are you managing yourself and benchmarking yourself relative to your peers and to the opportunity. When we look at this, on the left, you'll see, with risk, how are you thinking about your compliance visibility? Do you have visibility into 95% plus your state? Are you kind of in the middle with 25, 90%? Or is it really a situation where you're just trying to get your arms around what's happening in compliance there? And then compare that to how often do you deploy? Are you deploying, greater than monthly? Are you on kind of a weekly to monthly schedule? Or are you doing things on demand? And that balancing act of risk and speed is really a good way to think about how can you benefit from high velocity automation and how can you really start taking your organization and transforming it to what's possible here. So I want to do a quick questionnaire here and just ask folks, how frequently are you auditing your environment security? So I want to take a couple minutes and have you fill out the survey here just so that we can get a sense for where we stand on the, on our respective on audit performance here. So I'm just going to give a few seconds here for folks to fill that out. All right, I think we're having trouble with the survey question here, so. All right, here it comes. All right, so now I'll give people another few seconds to fill this out. All right, so let's jump to the results here. All right, so look at this. We have daily and weekly and quarterly are kind of running the same here. We have monthly and not sure as the leaders here. So again, it's really interesting, exciting for me to see this because as much as you could say, oh, being not sure of your publishing schedule is a bad thing. At the same time, it really shows that there's so much opportunity for you to benefit from a high velocity transformation as you move into the new world of automation and hybrid environments. All right, so one more question here. How frequently do you deploy code in your organization? Daily, weekly, monthly, quarterly, yearly, or not sure? So take a moment to fill that out. All right, just a second for our answers to come through. All right, we're having some delays here, so appreciate your patience. All right, here's the, so now here's the questionnaire. So let's get some answers in here and then we can move on, just get the pulse of the audience. All right.
That's the thing with demos and presentations, Matt, rife with filibuster opportunities.
Yes, indeed. Start blaming the platform, but that would be irresponsible. So again, a good. I think this is actually a pretty healthy healthy speed metric here in terms of how often we're doing continuous delivery of code here. So I mean, daily and weekly and monthly being the bulk of the stuff. That's pretty high velocity stuff. That's great to see. So when this stuff gets really important now is to think about the challenges that we're all facing where, hybrid is now the standard app model for modern app teams. When we are, facing our job every day, it's that, we have word to hear is, teams need to deliver all infrastructure on any app everywhere continuously. The way I like to think about this is that we all have 3 jobs to do at any given day. We have to ship the code that we are currently working on. We have to fix the stuff that we delivered yesterday, and we have to be ready to deliver on tomorrow's innovations and opportunity here. And this reality gets to be very, very challenging. You have to do things manually and also do a lot of phase change across your estate here. You think about the legacy realities and the emerging landscapes here. You have to balance monolithic app architectures versus the rise of service architectures and microservices. The runtime, is it physical or is it containerized with Docker or Kubernetes? Is your app running in the data center? Are you up to AWS or Azure? And so as you're looking at balance these things out, one of the things that I hear from customers is that there's a lot of concern about how do you think about automation when you're kind of pulled in these 2 different directions here? And how do you also think about automation when your portfolio could look like anything from having the microservices being running against a physical runtime and data center to where everything is really containerized and running microservices and completely in the cloud. And the reality is that it's not about moving completely to the cloud or being completely in containers, completely in a data center. If you're a company and you're doing things right now and you're not don't have the luxury of being a greenfield startup, you will be operating in a hybrid environment for the foreseeable future. I mean, even the quote here with Andy Jassy, who's going to be the proponent of being cloud first, cloud everywhere. He even says most enterprises are going to operate in a hybrid mode for many years to come. You see that this is the reality, and as you think about what's possible with automation, what's possible with maintaining high velocity, this is one of the commitments that Chef really makes to our customers is that we understand that you're operating in this mixed modality. We want to make sure that you can benefit from automation across your entire estate and not make trade-offs based on whether you're in a legacy environment or in the cloud here. And so with that background, I'd like to hand it over to Nick here so he can go and show you how this works in a real-life environment here. So Nick, take it away.
Thanks, Matt. And thankfully, we have a little time for me to introduce myself while we wait for this final poll to load. As Jamie and Matt mentioned, my name's Nick Rycar. I'm Technical Product Marketing Manager here at Chef. And among other things, I'm responsible for creating a lot of our demo and presentation environments, like the one you're going to see today. And what the poll we're hopefully about to see is going to ask us is, how much of your time is spent on unplanned work? And of course, this is the other thing that pulls at us as we try to prepare for building out hybrid environments, building out microservices for our apps, is all of the unscheduled work that gets in the way. From my previous life in sales engineering, what I would hear most from folks that aren't sure how to handle automation is, where am I going to find the time to do this? And what's sort of the paradoxical benefit is the more time that we spend automating our processes, the more time we're able to reclaim as we start working on new innovations. So it looks like we've got some poll results in. And yeah, the winner with a bullet is 25 to 50%. And reaching back into my life as a system administrator, that sounds about right. Whether it be trouble tickets, break fixes, what have you, there's all sorts of things that prevent us from moving forward with whatever our next project is going to be. So we're going to talk a little bit about what that continuous automation promise ends up looking like. And to start that journey, we first need to start by defining the outcomes that we're hoping to achieve. At Chef, our position is that successful organizations are able to outperform their peers on metrics of speed, efficiency, and risk, as Matt mentioned. In order to achieve that success, it's important to ensure that as we improve these metrics, we don't do so at the expense of others. So more frequent but more error-prone deploys can kill our velocity. They'll just pile on that unplanned work. More efficient deploys without a means to validate environments can increase the unknown risks to our systems. So the question becomes, how can we use automation to help us achieve all three of these goals in unison? So first, what we need to do is put in place a simple standardized cycle of development that gives us the ability to iterate quickly without losing sight of how our changes impact the overall security of our environments. As Matt mentioned, we call this cycle detect, correct, automate. If we have the means to detect deviations from our standards, correct those issues where they arise, and automate the process of doing both, we have the ability to publish code as often as our customers and colleagues demand, with the confidence that we haven't sacrificed its quality along the way. Chef helps us here in a few ways. First, we need to define a standard and evaluate our systems against that standard. In some organizations, those standards are already rigidly defined, as with those subject to frameworks like PCI, HIPAA, or forthcoming GDPR. In others, there may be a more loosely defined set of security standards, but in any case, InSpec is a tool that we can use to define our requirements, either via pre-written profiles that are available both in Chef Automate and on the Chef Supermarket, or via custom homegrown profiles that can be written in an easy-to-learn, domain-specific language and can then be used to scan our systems against the standards we set. We can then send those results to Chef Automate, where they're organized into filterable compliance reports that provide an aggregated overview as well as an auditable history of our system's adherence to the standards we've set. Next, we determine the proper remediation for any issues we uncover in this detect process. Using local testing tools provided in the Chef Development Kit, we can create and test these solutions quickly and consistently, whether on our local systems, bare metal development environments, or ephemeral cloud instances. Once we're satisfied with the solutions we've created, we can start applying them to nodes within our estate. As with compliance reports, Chef Automate provides an auditable history of all changes that we've made to the nodes we manage, allowing us to validate that our remediations have been successfully and consistently applied once they've been promoted. Finally, as we build these solutions, we can incorporate them into every aspect of our estate's lifecycle, allowing the automation of each system we're responsible for applied consistently regardless of team or environment. From creating a build process with Chef to ensure that all reference images adhere to a base standard, to automating the deployment and configuration of our applications, to creating fully fledged release pipeline for our infrastructure code as well as our application code, there's no end to the ways we can improve our efficiency through Chef automation. If we follow that same detect, correct, automate cycle along the way, new automation is additive, and we never have to worry about old issues resurfacing. By using a standard tool across the board, it becomes even easier for disparate teams to collaborate and work towards your organization's shared goals. So for today's demonstration, I'm going to be taking on the role of an operator at a fictional company, Planet Express. And as a new Chef practitioner, we're going to get a chance to see this development cycle in action as we detect, correct, and automate our way to delivering on improving those speed, efficiency, and risk metrics we mentioned, and start implementing continuous automation. So before we dive in, it's helpful to start by getting some data out of our environment. So we're going to start at this first detect step and see how Chef Automate can be used to start gathering valuable data even before we've updated any configurations. We'll also see how by adding InSpec audits to our nodes, we can start evaluating the security of our configurations. And with that, I'm going to go ahead and fire up my screen share. So in just a moment, you should be seeing my demonstration environment. And Matt and Jamie, let me know when we start seeing this coming through.
Good.
When it loads, oh, excellent. Thank you, Jamie. So what we're looking at now is the aforementioned Planet Express application. Our ultimate goal is to start automating the deployments of this app. But before we can do that, we're going to first take a look at our current running environments to see whether they are securely configured. So here we're going to hop over into Chef Automate, which I've started setting up for my environment. And typically the first order of business is bootstrapping the servers that we wish to manage, which is a process of installing our agent, the Chef client, which will allow new nodes to pull down any new configurations that we've defined and report their results back to Chef Automate. Take a look here. We've got a few nodes in our environment, 7 total, some dev, staging, and prod machines. And if I take a look at dev 1, we can see that my nodes have been bootstrapped, but as of yet, we're not doing anything to them. No resources are being run. There's no run list, which is how we organize the tasks that we'd like Chef to perform. We just get information about the machine that's automatically collected every time Chef runs by a tool called OHI. So if I hop in here and I say I want to learn about the memory of my system, this will actually look through what is a hash of all the information OHI has collected and let me look at the data it's collected about my memory as far as what the usage data, statistics, et cetera, were the last time this machine checked in. Now, Chef Automate comes preloaded with a variety of ready-to-use profiles. So if we want to start evaluating the security of our systems, we actually have a means to get a head start here. If we click on the profile store here, we have a list of 92 available profiles, and today we're going to grab the Linux security baselines. We hop on through here. I can install this on my Automate server simply by clicking this Get button, and we have a list of controls that this profile contains. Now, each one of these controls defines a single specific thing that needs to be validated by this profile. So for example, if we take a look at the package 2 control here, it specifies that the telnet server should not be installed. When we dive in further, we get some further explanation, letting us know that telnet uses unencrypted communication and may be a security risk, and also provides a link to the NSA guidelines from which this rule is derived. We even have the ability to look at the raw source code of this InSpec control and see how InSpec is designed. Here we see an example of a resource in InSpec, the package resource, where we're looking for the presence of the telnet D package and setting an expectation that it should not be installed. So now that we have this installed in our system, if we hop back into the profile store here, I see I have one profile installed. I'm going to need to start updating my nodes to start evaluating this profile. In this case, I'm going to update my node's run list so that it runs these audits every time my nodes check in with the Chef client. And here I have an update run lists command I've made myself so that I can go into the development, there we go. Don't try to talk and type at the same time, folks. I'm going to go ahead and add an audit recipe to my nodes. So as alluded to earlier, a run list consists of these recipes which are defined within entities called cookbooks. Here I'm adding the audit recipe out of a cookbook called DCA demo to my development nodes. And this will ensure that when Chef checks in, it's going to run the audits I've specified within that recipe. Now that I've got that installed, I'm going to run another quick command, invoke Chef client in development. This is going to go ahead and connect to all of my development nodes, the dev 1 and dev 2 machines, and apply whatever run list we have specified, which now consists of a single recipe, that audit recipe. And we'll see here in the background all the stuff that Chef is doing. And this is what we call in Chef parlance a converge. The node is going to download whatever recipes we've defined in our run list, as well as any dependencies they might have, and update the local configuration as those recipes specify. Now, our audit recipe isn't actually updating any configurations. It's just making sure that the InSpec utility is installed so that we can run our audits, which will be available in the compliance tab once these runs complete, which it looks like they have. So if we go into compliance now, we can see that Dev 1 and Dev 2, which we've just scanned, have indeed encountered some failures. 26 to be specific. We can dive in here to see some more detailed results. And indeed, we have, of the 52 controls we've evaluated, 26 came back with failures. And I can dive in to look at the nature of those failures. So if we take, for example, the login definitions here, the control checked multiple things, some of which passed, but we have a UMask failure, we have max days for passwords, so a few things here that need to be solved. Now, even though we've uncovered more failures than we might have hoped for, what we can see is what specifically we need to target in our remediation so that we can plan accordingly and move forward in our automation processes. So what I'm going to do now is I'll run a little script in the background that is going to update my staging and production environments with those audits as well and bring everything up to speed so we can get ready for step 2. So in step 2, we're going to actually start correcting these issues that we uncovered in detect. Now that we've detected them, how are we going to be able to address those issues safely? So what we'll end up seeing here is how the same processes that we use to start collecting audits can also be used to apply our remediation. Just as with our audits, with Chef Automate, we'll have the ability to evaluate how our changes performed in development before we update production and make sure that we're actually going to solve the problems we've come in here to solve. So let's see, is my script finished running? Just about. In the background, it's doing that same run list and Chef Client rigmarole on the rest of my environments, so that when all is said and done, we'll end up seeing a few more than 2 nodes in our compliance view here. 5 getting warmer. This is what happens when my scripts are slower than my mouth. All right, script has completed, and that should mean that, yes, we now have a total of 7 nodes, which I'll apparently need to refresh to get the heading to agree with me there. There we go. 7 nodes, all with the same variety of failure that we saw on Dev 1 and Dev 2. So, since we last saw our environment, we've applied the nodes across the board, and now we're ready to start fixing the problems we've uncovered. Thankfully, our DCA demo cookbook has another recipe for us. We've developed a new recipe called hardening that is hopefully going to remediate the issues we uncovered in part 1 so we can move forward to our original goal, which is starting to automate the deployment of our application itself. Now, for the sake of brevity, I've made another little helper function for myself called DCA update nodes. This is just going to combine the last 2 scripts that I ran, update the run lists, and then converge the nodes once they're updated. And this time, we'll be using the hardening recipe. As before, you see here, we're using the same cookbook, DCA demo, applying the hardening recipe. Quick sidebar for folks that have used Chef before. The commands I'm running here aren't Chef commands. They're little scripts I wrote that are using a utility called Knife to update my run lists and connect to my development nodes over SSH to handle their converges, which in turn are making API requests to the Chef server over HTTPS. So now we see the audit recipe was still in place in those run lists, but the run lists have a little bit more to do now that our hardening recipe is in there as well. When our nodes finish converging, we'll be able to see the steps that Chef took to configure them. And when they complete, we'll be able to see all of that information available to us in the Chef server, or the Chef Automate server, rather. What's important to note, and it looks like the runs are done here, so we'll have a look, is that Chef is only making the changes that it needs to make. Now when we look in our node detail, we see that the run list is now populated with 2 recipes as opposed to when we started out and the list was empty. And it is now evaluating 44 resources that have been defined in those recipes. Of those resources, we can see here that 29 of them are unchanged. These are items that were found to already be in their desired state when Chef ran, and so Chef is just noting it didn't need to take any corrective action. If we go into successful, however, we can see the 15 resources that did make a change, like installing the audit D package or updating its configuration. And with any luck, now when we go into compliance, I see a little bit of blue. Indeed, taking a look at our nodes now, Dev 1 and Dev 2 are passing their audits. I can go in and review that indeed all of my controls have passed, and I still have access to the scan history. So if I wanted to evaluate the previous failure state, I can do so while also confirming that my machines are now compliant. While there are a number of ways to run these audits, a benefit of running them via the Chef client like this is that every time we evaluate a change, like the changes my hardening recipe applied, we automatically get an audit so that as we change the configurations of our systems, we never lose sight of their security and haven't introduced any unexpected regressions. Of course, if we've applied a fix and we're now compliant, but our site doesn't load, we might have a problem. Last step, of course, to make sure I can still browse around, everything's looking good. Planet Express can continue selling their space prints unhindered by this update. Excellent. So with that, we now have some progress. And just like before, I'm going to go ahead and simulate staging and productions hardening in the background as we get ready to move on to the final stage, automate. So in this final step, we're going to add a new recipe into the mix to start deploying our website. As you might expect, the process for doing so isn't going to differ much from what we saw in parts 1 and 2. In fact, deploying our site is pretty much the same kind of thing as applying our hardening scripts. We're simply taking the tasks that it takes to deploy and configure our application and applying them the same way we applied our security updates in step 2. So once we have that recipe defined in the process, and regardless of that recipe's function, what we're doing in the command line here isn't going to look any different. This makes, as mentioned earlier, our automation gains additive. As we create this new functionality, we don't lose the solutions that we created in parts 1 and 2. We'll continue to get feedback on the state of our compliance after we've deployed changes to our site, and we'll continue to make sure that our hardening requirements are being enforced all at the same time. So let's see here. I mentioned to Carter earlier my love of filibustering. It looks like my script is still a little running to do, but we can actually see in the background here what it's doing is pretty much the same as what we were doing in the command line, adding a new recipe, install site to some machines, spoiler alert. But we also see what that Chef client run ends up looking like in the console. So when we're running these on a system, we get a lot of feedback. When each resource is evaluated, it lets us know whether that resource is taking any action or not, as well as we see some examples of in here, providing us with diffs of any files that were changed along the way. In some cases, and here's an example here, that's what the unchanged resources end up looking like in the command line. So it's showing that our sysctl config directory already exists and is up to date, so it's moving on to the next task. All right, so let's see here. You don't necessarily need to wait for that to complete, but when it does, oh, hey, speak of the devil. So it looks like the important part's done, which is that we've applied our hardening to the rest of our environment, and now compliance is showing us that pretty blue ring that we were hoping for. The only thing that remains to do is start applying that install site recipe to our development environment to make sure that we can actually deploy changes to our site via the same process. So here, as before, I'm going to run that DCA update nodes, but instead of hardening, we're going to use the install site recipe. And as before, it'll update our machines with the appropriate recipe in their run list and reconverge. Now, when these converge, we'll see some new resources being evaluated. Since now we are deploying updates to our site and taking care that things like Apache, Java, and MySQL are properly configured. When the converge completes, as before, we'll be able to reload our nodes view, take a look at our dev server, and confirm whether the change was applied successfully. And of course, the proof will be in the pudding. We'll see a new version of our app ready and waiting for us if everything goes as expected. And as we're waiting for this to complete, a quick reminder to folks that if you have any questions at the end of this webinar, we'll be doing some Q&A. Make sure to go ahead and hit up the little Q&A module in the webinar software and drop us a line. We'll be sure to hit you back up. All right, it looks like the run is complete. Let's see what happened. So once again, in the node view here, I can hop on to one of my dev machines, dev1, and can see that a new run has just completed. This time around, we have a new recipe in our run list, and we see now it's a total of 99 resources being evaluated. Some of the resources that ran in our last run now don't need to run because things are already in the state that they needed to be in, but we have a few new resources being applied, setting Java home, importing database backups. So with any luck, my Planet Express site should now have our new version deployed with Chef. And most importantly, I haven't lost sight of compliance. I can still see here that none of my nodes are showing any issues. And if I want to be very sure, I can confirm here once again that a new scan did indeed kick off when this Chef client run happened. So we see here, everything that's happening in our environment is highlighted for us to evaluate, and we can see a full audit trail of the history of our systems. I can even go back to that initial state before we had applied a single configuration to this box. So to wrap up, I'm going to go ahead and stop screen sharing, and let's see if the AZ continues to play nice with me. But with any luck, we should be back on the step 3 automate slide. Jamie and Matt, am I still coming through on the audio?
Yes.
Excellent. The webinar gods are smiling on us today. So we can come into our wrap-up here and touch back on some of those software success metrics we covered at the outset of the presentation. So what we saw in step 3 there was that as we add new pieces of automation to our environment, we start getting more and more information back from Chef Automate. And as these new features are built, Automate is showing us the changes that we made node by node and provides a full history of those changes for easy reference. We now have the ability to apply new audits, remediations, or deployments on demand, and a means to validate that systems were accurately configured with each Chef run. By running audits as well as our configurations, we're continuously evaluating against our security standards and never lose sight of old problems thought long fixed and spend less time resolving those old issues and more time creating our next great innovation. So before we dive into the Q&A, I want to do a quick shout out for Learn Chef Rally. So if you've ever been to Learn Chef before, it's seen a lot of updates this past year and badges you can collect, new tracks and modules. And in particular, to sort of tie in with the themes we covered in this demonstration, I wanted to call out a few specific tracks. So what we're seeing here, and these are all available on learn.chef.io, is first demos and quick starts. So if you saw that Automate server and you want to get hands-on quick, this is the best way to do it. It'll give you a pared down version of the Automate server you can run on your local desktop or laptop and get a feel for what it looks like to add and edit nodes within Automate. As we go towards the specific detect, correct, and automate solutions we saw today, the compliance automation track will give you an introduction to InSpec and show you how you can start detecting issues in your environment, either via some of the pre-written profiles like what we saw today, or via some profiles you create yourself through that DSL. After that, there's the infrastructure automation track, which is going to cover Chef itself and applying configuration changes to your servers. And it will dive into exactly how Chef is doing some of the things we saw today. Like InSpec, it consists of resources that we can use to take care of commonly undertaken tasks, as well as a fully configurable language that you can modify and edit for your edge case needs. Finally, the continuous automation track is going to get you more familiar with Chef Automate itself and talk you through some of the ways that you can use it to combine what you've learned in the previous tracks and start getting insight into how things are performing in your environments. And with that, what questions can we answer for you folks today? Let's go ahead and take a look here. Looks like we have a bunch of questions in the queue, so I'm going to start diving in. So let's see. I have a question that that folks have looked at using Automate to do security compliance testing and asked whether sometimes folks are using Automate to do application testing as well. And the short answer is yes. And the qualifier there is it's not necessarily meant for specifically code testing. Usually we'll use language-specific linting and unit testing tools for that kind of stuff. But what it is very good at doing is validating running states of things. It ties into, or InSpec specifically, ties into our testing harness, Test Kitchen, so that as we are writing cookbooks that will either configure environments for an application or actually deploy those applications, we can use InSpec to validate that those happened correctly. So really any scenario where you have an expectation and you are looking for a yes-no answer as to whether or not that expectation is met is probably a situation that InSpec will fit into nicely. And when we add Automate into that equation, we get those compliance reports that we saw, where we can assign a weight to any of the individual things that we're validating and get reports back letting us know whether we have major, minor, critical, et cetera, issues to be solved. Also worth noting, what we saw in the presentation was InSpec triggered as part of a Chef client run, which, as mentioned, has the benefit of tying into your configuration automation processes. But it's also runnable as a command line utility, and there is a beta in Chef Automate of an agentless scanner from within the UI itself, which can be useful for evaluating nodes that are not yet bootstrapped with the Chef client. So any node that can be accessed over SSH, or in the case of Windows, WinRM. But also there are new profiles for evaluating things outside of traditional servers, like our cloud modules that will allow you to do some inspections of, at present, AWS, Azure, and vSphere via similar match case statements. So let's see. Since we spawn new EC2 nodes from the command line using Knife, how would the workflow differ, if at all? So what this is actually referencing is, I mentioned briefly during the demonstration that my little PowerShell scripts were wrapping a bunch of Knife commands. And Knife is a command line utility that's part of our development kit and is pretty much your primary way of interacting with the Chef server or Automate server, as well as the mechanism that's used to bootstrap a new node. Now, if those nodes already exist, so if we're using either bare metal machines, VMs, or just cloud machines that are long-lived, we can bootstrap over same protocols, SSH and WinRM. But there are also utilities, as alluded to here, for things like Amazon EC2, where we can actually configure Knife with our cloud credentials for Amazon, Azure, Google Compute, what have you, and launch new instances with that same Knife utility that will bootstrap and apply our recipes to them as they're launched. So in this particular case, the workflow wouldn't really differ. If, for example, I wanted to add a new node into this environment, which incidentally is an Amazon environment, and I have those 3 recipes that I want to apply to it already written, I would be able to use something like that Knife utility to create the node, assign that run list to it, and it will go ahead and bootstrap it with whatever source image I define, which incidentally, these are just the stock Ubuntu, I think 16.04 images off of Amazon. So this tends to speak to the cloud agnosticism you get with automation. And this is something I think Matt alluded to as well in his presentation, where as we define these pieces that we automate, spinning them up on premises in AWS and Azure in whatever provider you use shouldn't look terribly different. Ultimately, installing Apache is still installing Apache. So while you may have some per environment differences that are accounted for, the process of actually configuring these things becomes a lot less tied to any particular implementation and helps make good the promise of operating in those hybrid models. So let's see, is InSpec tied to Chef Automate, or is it available in the vanilla Chef server? So the InSpec profile store is tied to Chef Automate, where we're loading those InSpec profiles from. However, InSpec itself is an open source tool. And in fact, many of the profiles that you can run are available on the Chef Supermarket as well as open source profiles. So where does the line get drawn between vanilla InSpec, Chef server, and Automate server? InSpec itself, part of the Chef DK and usable as a command line utility to run agentless scans at a single point in time. And it'll give you a few different formats. You can get JSON formatted, or I think like CSV formatted, stuff back from it in the command line. If you are using the audit cookbook, you can either, if you have an Automate server, create those compliance reports. So the compliance reports are a part of the enterprise solution. Or again, like with the command line utility, can be used to generate a local audit. So in summary, what you get with Chef Automate is the ability to store compliance profiles there as opposed to pulling them from version control or local file system. You get the ability to create audits and get a run history of those audits. You also get access to some CIS benchmark profiles based around some Center for Internet Security standards that are specific to a Chef Automate license. Can we see the custom commands code? Absolutely. So this is really a simple PowerShell, which you'll see very quickly. I haven't done a whole lot of PowerShell dev, but at the very least, let's get this up here. I'm going to do another quick screen share because this is actually from our demo environment, which we have actually open sourced the sort of environment project we used to build it. It's built up from a bunch of Packer image building processes that lives on the Chef CFT account. And let's see about where that lives real quick. It's on my workstation, and I have a really quick and dirty, no, not my recipes, in my files, PowerShell script that I use to simplify things for demonstration purposes. There's my DCA functions. So let's make this a little bit more legible. So the update run list function basically grabs my environment and recipe parameters and runs for each node that it finds in that environment. So it's running this nice node list with a parameter flag to query a specific chef environment. And for each node it finds, it's running this nice node run list add command, which is how via the command line utility you would append a node's run list. And Invoke Chef Client is doing something similar using a command called knife SSH. And knife SSH allows us to connect to one or many machines defined by a search query. So here we're looking for any node whose environment is the environment we specified and running the command sudo chef client on that machine. And then Chef Client runs locally and grabs all of its pertinent configurations from the Chef server. And then the combination function just does both of those things and does some fuzzy environment matching, so I don't have to type out the whole word in development every time I run the command. Fun little peek under the hood there. Thanks for that question. Is Chef the appropriate place to apply OS patches once the machine is part of the Chef pipeline? So the unfulfilling answer to that is it depends. And oftentimes that is going to depend on what the patching process entails. So ultimately, going and running a patch via Chef is something you can do, and in cases where, and I know particularly happens on a lot of Windows systems, patches may require reboots, and there are reboot resources in Chef. But as with anything, whether you would want that process to be an automatic application or something that is a triggered promotion is something that comes down to sort of what processes and flexibilities you have in place. Some shameless self-promotion, though. There is a webinar I did a few months back that should be available on our YouTube page that talks about using a feature of Chef Automate we haven't discussed today called Workflow to help take some of the pain out of the patching process. So using InSpec to do the detection part, and there is a pre-written recipe that will go and reach out to whatever local package repositories are in use to see if there are critical updates that are out of date, and a way to look at what promoting those updates looks like. Really taking the process we did here with the staggered introduction to dev and beyond, but doing it more formally through a pipeline as opposed to the way I did it today from the command line directly. So yeah, if you would like to check that out, we'll make a point of putting that in the links when we post the review of this. But it'll be, I think, from back in February or March or so. And it's purposeful patching with Chef Automate. That's what we called it. Let's see here. So looking to use Chef to build AMIs in AWS, and then that would be used to deploy infrastructure. The plan is to bootstrap the node in step 1 with a generic node name, and then when multiple instances are created in the new image, you would rebootstrap to new names. Gotcha. So this gets a little bit into specific implementation details, so I'll try and restrain myself from going too deep down a particular recommendation here. But I'd say at a high level, that process is a very common one and very similar to what we're doing in our demo environment. What is nice about using Chef to build images is that a lot of popular tools for building them, what I'm using is Packer from HashiCorp, have some Chef provisioners built into them so that as they create the image, you can have some Chef recipes get applied to those images before they're snapshotted. What it allows us to do is have a artifact that acts in some ways like a golden image where it's very quick to deploy and you don't need to spend a lot of time updating it, but doesn't have the drawback of traditional golden images where you don't have any insight into how they were created or what they were created with. Where you just use a tool to generate those images, and then once they're bootstrapped, you can apply any updates to them, either if you're in a very high velocity environment and have the ability to spin down and spin up instances. A lot of times folks will just opt to launch a new instance, and particularly when we're talking in the immutable world like containers, same kind of thing. Or if you have longer lived instances, that's where the beauty of the test and repair functionality of Chef, where it will first check and see whether things are in their desired state. So only the delta gets applied as new updates are made. As far as the naming conventions go, I won't go too far down that line, but a phrase you'll end up hearing a lot is treat infrastructure like cattle and not pets. And what that ends up meaning is that at a certain point, when we're getting a lot of use out of automation tools like Chef, the designation of a machine becomes less important, because that same search query that I was using, say, to apply changes to my development environment can be used to grab any other data about our systems, from profiling information, show me all the systems that have more than 64 gigs of memory, to, since we're defining their configuration with Chef, information about them. Or I can say, rather than show me Web 01 through Web 05, I can say, show me all machines that are running my web app in production. And so as we have to scale up and down, it means that we're less tied to potentially more static conventions that can come along with the 01, 02, et cetera, naming conventions and the like. And so let's see, looking at the clock here, it looks like we're about 6 minutes to. I might have time to squeeze one quick thing in there. Oh, this looks like a perfect one. If we retire a server that has been scanned for compliance, is the history of that server retained for audit? So yes, it will stick around until you opt to remove it. I think there may be a rotation threshold that I would have to check on, but ultimately you will have access to that data until it gets rotated out or you remove it. The node itself, if it hasn't been deleted from Chef, will actually show up as missing in Automate, which is a great way to find potentially orphaned instances and give you a reminder either there's something wrong that I need to address or it's time to delete that node from Chef.
Great, thank you so much.
All righty. No problem, my pleasure.
And also thanks, Matt. Since we're almost out of time here, we'd like to thank our audience for your live participation today. For those of you that submitted questions that we didn't have time to answer, we'll go ahead and follow up with you via email and address those in the next week or so on the Chef blog, where we'll recap everything we covered here today. As a reminder, a copy of today's slide deck and additional help materials are available in the resource list widget at the bottom of your screen. We encourage you to download that slide deck and bookmark any links that you may find useful. The on-demand version should be available by tomorrow, and we'll email you as soon as it's ready. Any closing remarks, Nick, Matt?
No, just thank you very much. Fantastic questions, and I'm looking forward to seeing what cool stuff you guys find to automate moving forward. And so if you're doing something amazing, please let us know, because we'd love to profile that in our blog and other ways. But thank you very much for your time today.
Indeed, I'll sort of echo that. Thanks everyone for joining us. When we're not here doing presentations, I can also be found sometimes in the Chef Community Slack channel, which is another great resource to check out if you're looking for some help or just have questions or want to talk shop.
All right, thanks everyone. Have a great day.